Welcome to Energy Talks, the podcast for energy nerds and inquisitive folks who enjoy interesting conversation. I'm journalist Markham Hislop, and today's guest is Dr. Alex Holland, who is a technology analyst for UK-based research firm IDTechEx, which just released a report about advanced lithium-ion batteries and trends over the next decade. So welcome back to Energy Talks, Alex.
Thanks, Mark.
Look, this is really interesting because one of the things that's become apparent, especially with the incoming Trump, since Donald Trump and his administration took over in January, China's driving it. We thought that maybe under the Biden approach, that the United States might invest enough, innovate enough, and adopt enough to catch China at some point. But Trump's dismantling of the Biden approach now pushes that back and makes it less doubtful. So is that the real top line story here? The fact that China is innovating so fast, scaling so fast, exporting and growing so fast that it really over the next decade is going to just utterly dominate the battery industry.
Yeah, I think obviously there's always a little bit of a nuance involved, but certainly China has got a substantial head start. It's scaled very quickly over the past 10 years. It's got this huge domestic market which it can serve. It's had support, consistent support, policy support from its government, which has helped. And it has succeeded in developing various battery technologies and commercializing battery technologies which have been, suitable and desirable from consumers. So certainly China is leading the way. It's got the scale now in terms of manufacturing capacity across the supply chain. You've got vertical integration from major Chinese players, which has helped their bottom line over the past year or two, where we've seen others kind of struggle a bit more, even within China. So certainly it's got that big head start, and it does continue to innovate. But that's as you mentioned, kind of looking at those advanced and next generation technologies is potentially an area where other regions might have a chance of catching up and kind of capturing a piece of the pie, even if it's not necessarily a straightforward task.
Yeah, it seems like in terms of lithium ion chemistries, China may in fact not be catchable. And I'm thinking here primarily of BYD. So a month ago, it introduces this new charging infrastructure architecture, where it's the megawatt charger. You
Sure.
get 400 kilometers of range in 5 minutes. 2 weeks later, CATL, the world's biggest battery company, comes out with and I hope I'm pronouncing this correctly, Shenzing, the LFP, lithium iron phosphate
Sure.
cell, which gets you 520 kilometers in 5 minutes. That all of that, are we reaching the limit of lithium ion? I guess is a good way to start this conversation.
Yeah. So broadly speaking, yes. In particular, when you look at energy density, so watt hours per liter or watt hours per kilogram, we're starting to reach the limits of what the current iteration of lithium-ion batteries can produce. And when I say that, I mean a graphite-based anode, which is typically what's used at the anode side of the cell, and then either an LFP or your NMC, NCA type cathode material. So for those types of designs, we're starting to reach the energy density limits. To a lesser degree, we're also starting to reach limits in terms of fast charging. But this is where some of those announcements you mentioned, BID and CATL, are really interesting. And this is what China and the Chinese kind of industry has done so well. It's almost these iterative steps forward, which they've taken continuously to push kind of actually almost current generation technology forward just by optimizing those materials, those cell designs, those battery pack materials. And it means when you've got other parts of the industry looking for that next big game-changing technology, they're competing against a moving target, right? It used to be one set of performance parameters. Now it's as you say, megawatt charging, 5 minute fast charging, so on and so forth. So they're competing against that moving target, and that's what I think China's done so well. It's iterating continuously and continue to push that envelope.
A couple of weeks ago, I had an expert on talking about solid state batteries.
Sure.
And there were some obvious advantages, higher energy density. And this was a North American company, so they were talking about the ability to retain charge in a cold environment, as well as charge in a cold environment. So up in Canada, we often have winters where you get minus 30, C. It's pretty cold.
Sure.
And while lithium ion has performed reasonably well, at least anecdotally, that's what I'm hearing. A battery that can keep its charge and then easily be charged at minus 30 would be a huge advantage. You could see that being an advantage. But it would appear that with the advances that BYD and CATL have brought along, you really, for the average driver, 400 or 500 kilometers in 5 minutes, you're kind of at the equivalency now of a combustion engine, in terms of fueling and performance and so on. And that makes you wonder if, are we really going to need these next generation innovations like solid state batteries?
Sure. Yeah. No, to a certain degree, I agree. Certainly, with these announcements recently, obviously a lot of the focus was on fast charging and safety as well, and kind of some low temperature performance in there as well. What wasn't kind of reported as much with those couple of announcements was things like how big those batteries were, what energy densities you're going to be getting from those LFP packs. Having said that, they're not going to be the highest numbers you've seen. But having said that, as you say, for your average driver, assuming the kind of the charging infrastructure, if we're talking about EVs here and kind of consumer electric cars, assuming the infrastructure exists, it's likely to be good enough, frankly, and that fast charging capability really helps kind of alleviate any concerns for longer distances there. Having said that, in places like Europe and certainly North America, the US, there is still a preference for that higher driving range, those higher range density kind of battery packs, therefore, as a consequence.
Is it fair to say, Alex, that we're starting to see the battery industry differentiate? So you have different chemistries, different energy densities for different applications, because I can see where a solid state battery might work really well for long haul trucking, for example, where energy density and ability to charge and so on could be a real game changer versus diesel. Whereas the average person running around town, that's just not as big a deal. And then the lithium iron phosphate battery that can charge in 5 minutes, doesn't matter if you get 200 kilometers or 400 kilometers, it's all good enough. No one really cares, especially if you're charging in your garage. So is that what we're seeing? Is we're seeing more specialization within these niches?
Yeah, absolutely. And I think as the battery industry grows, right, there's more space for new solutions to meet certain niches and market segments. So if we take the EV industry and the electric car industry specifically, um, putting China to one side for a moment, the adoption is very much being within those higher cost premium segments. We're starting to see a shift away from that now, and you're starting to see battery makers, auto manufacturers starting to target entry level, mid level, premium segments. And so those premium segments, you could have things like, as you mentioned, solid state batteries, which are likely to come at a cost premium, silicon anodes, super high nickel, cathodes, those types of things, which are going to be very high performance, but are likely to come at a cost premium. And then at the lower end, we're talking about ultimately LFP at the moment as the only real kind of option there, but there may be some alternatives coming up as well. But also just to mention, it's not just about the electric car market. You could be talking about other industries, kind of robotics, industrial robots, off-road vehicles, where they're going to have different performance requirements, so on and so forth. And that's going to see differentiation within the battery industry as well.
I interviewed an entrepreneur yesterday from Latin America. He was focusing on Costa Rica, but a big part of his business model, he's an engineer, and he takes various components like solar panels and battery storage and other inverters and whatever are required, and then he engineers these custom packs along with his own software for things like manufacturers who can't, are worried about an aging, unreliable grid in many parts of Latin America. And the key part there that I want to focus on is batteries.
Mhm.
because a storage battery at the utility scale or at the commercial business scale, that seems to be got to be a huge market for a lot of the innovations you're talking about here, especially as utilities, system operators, regulators are looking to both expand generation in response to 4 to 5% a year demand growth and the need for resilience and reliability. And so, all of these changes you've talked about in your report, we've been talking about EVs, but in fact, the battery energy storage system, the BESS system, that might be the biggest beneficiary.
Yeah, so what I would say there is you're absolutely right. The stationary storage and battery energy storage systems. I mean, last year, for example, it continues to go from strength to strength. Really grew kind of demand grew rapidly there, even as demand for EVs slowed down a little bit, certainly outside of China. So that's a hugely important sector. But with respect to kind of performance requirements, LFP batteries, their low cost, relatively high safety profile is really kind of um, very suitable for those stationary energy storage systems, and LFP is widely used as kind of dominant within the stationary storage sector. I think what's interesting is perhaps over the longer term, as we start to need longer durations of storage over 8+ hours, as we have higher percentages of renewables, you might start to open up possibility of incorporating different types of technology, different battery technologies. You're talking about iron air, maybe redox flow batteries, but also alternative kind of technologies as well, things around, liquid air storage or even kind of hydrogen. So there is absolutely scope there, and actually for that longer duration market, which doesn't really exist yet, but is starting to grow. We expect over the longer term, there's scope for a wider variety actually of non-lithium battery technologies to enter the market and compete.
Now, there have been a number of alternate chemistries that have been under development for a long time. The zinc ion and lithium sulfur, lithium metal, and on and on. But it looks like sodium ion is going to be the next big trend. Can you tell us about that?
Yes, I think we always have to be really careful when we're talking about the next big thing. As you always kind of the battery industry, I think, in general in the past has suffered from the silver bullet being, commercialized and being ready, and then not quite having the impact that was expected. For sodium ion, I think we need to be particularly careful. Over the past few years, we've seen the price of lithium ion materials and therefore lithium ion batteries as kind of part of that drop quite quickly, and so ultimately take away a big part of the value proposition of a sodium ion battery. Our view is very much sodium ion still plays a role as almost a hedge, and longer term as well for the stationary sector, but competing against lithium ion is always going to be difficult. It obviously has some performance benefits with respect to rate capability, maybe even low temperature performance. We saw that announcement from CATL, maybe developing kind of hybrid packs where a sodium ion battery portion takes care of cycling at kind of low temperatures and high rates. But we have to be careful about kind of the real value proposition that sodium ion offers at the moment, given where we are with the kind of the price environment with lithium ion batteries.
One of the discussions I'm involved in all the time because Energy Media covers both the all of the clean energy technologies, including batteries and EVs and utility scale storage, but also oil and gas. And so a lot of the oil analysts, for example, will say, well, yeah, but there's going to be innovation in internal combustion. No, there's not. I mean, we've basically come to the end of combustion engine efficiency improvements. So there's not much coming there to either lower the cost or increase the efficiency. And on the fuel side, you know, oil might get a little cheaper, but then sometimes it gets a little more expensive. I mean, it depends on the market. But on the battery side, which is the heart of an electric vehicle, there's so much innovation, there's so much cost reduction, so many iterations within existing chemistries and technologies, and so much innovation and research into new chemistries, new technologies like solid state, that it seems like this period covered by your report, which is 2025 to 2035, this is just going to be this is the California gold rush. This is the kind of almost like a golden era for batteries, and there's so much coming that it's going to, in some ways, revolutionize how we manage our grids, how we get around our transportation. It just seems the amount of innovation is just mind-boggling. That's the way it looks like to me from the outside of the industry.
Yeah, and I, again, broadly agree, and I think that's why maybe taking a slightly wider view, longer term view is so important. Because if you were, paying if you've been paying attention to the industry over the past year and a half, there has been no shortage of kind of negative sentiments, paused plans for expansions from European or US players, but actually in terms of the technology, there's various different things, both in terms of current generation technologies and kind of optimizing those materials and designs, as well as your next iteration of technologies, whether that's solid state, silicon, new cathode materials, whatever it may be, getting close to commercialization or really starting to be deployed in some cases, that we are going to see battery performance continuing to improve, battery prices continuing to improve, not necessarily all at the same time, sometimes separately, but over the long term, we're going to have ultimately our view is we're going to have battery technology which enables an EV that will have equivalent performance to an ICE vehicle and actually be kind of very much cost effective once you take into account the cost of refueling and so forth. And we're relatively optimistic that will take place over the next 5 to 10 years.
What about the West? We talked about this a little bit earlier, in that China is forging ahead. Trump's policy changes have hampered North American battery manufacturers. We've got some problems in Europe. Northvolt has gone bankrupt. Um, this seems to be a real problem for the West, falling behind on batteries. Is there any hope for the West catching up? And if there is, which part of the segment is there hope?
Yeah, I think it's important that there is, the industry continues to keep pushing forward in outside of China. Certainly, you've got some of your South Korean and Japanese players continuing to kind of push forward with their technology platforms, as well as production capacities and expansion, so on and so forth. In terms of Europe and the US, I think some of the lessons that we need to learn is that competing with those established companies, those established players trying to produce current generation cells, batteries, and compete on price and kind of efficiency, there is always going to be a very challenging endeavor, certainly without a lot of kind of policy support in place. And so as we kind of argue, actually looking at the next generation of technologies is probably one of the ways in which European and US industries might be able to play a more important role and a more significant role in the industry, which is ultimately at the moment very much controlled by China and to a lesser extent, Asia more widely.
Um, One of the issues that came up yesterday in my interview with the fellow from Latin America is that it's clear that the technology he's going to be accessing will be manufactured in China. But there's a lot of value to be added and a lot of differentiation by the system integration, system level design. So China may very well, churn out great quantities of cheap, good batteries and cheap, good equipment like gear that goes into a utility scale system or even into electric vehicles. But the design around that, the software around that is becoming, it seems to me, more and more critical a part of this industry in terms of which, the industries that use batteries. And I just wonder if you could comment on that.
Yeah, so I mean, in general, both for those stationary systems, even for EVs or consumer devices or whatever it is, the software, the battery management system, those aspects are obviously, critical, and I think are starting to get more and more intelligent in terms of things like charging profiles that don't damage the battery even when you're fast charging, but also things like dispatch organization, as well as kind of maintaining batteries, make sure batteries are operating in kind of safe windows of operation, and making sure you understand where degradation may be happening or where certain assets might be undergoing kind of excessive degradation. And obviously with that software, obviously looking at the software side, it might be slightly easier for those industries, those regions to compete without having to rely on that mass scale manufacturing capability and the supply chain that comes with that.
While we're talking about the West, so we'll call it the global North, catching up, one of the things, and this comes from my observations primarily in Canada, but secondarily in the United States, and that is policy plays a really key role, industrial policy. And in democracies, in order to implement those kinds of policies, which require a lot of spending of public monies, you need to have a political constituency built for those policies. There needs to be public support. Otherwise, what happens is the next government comes in and then, they do away with it, like, as what happened with the United States when Donald Trump became president. And I'm a little dismayed, and I don't know what it's like in Europe where you are, but in North America, there's a profound ignorance amongst the public about the role that China is playing in clean energy technologies generally and batteries specifically. And they kind of, I get a lot, my viewers will comment quite often, or they'll email me or DM me on social media, and they'll say, "Oh yeah, but China, burns coal, or China uses slave labor, or China has lower environmental regulations." And really, all they're telling me is that I'm just discounting China. I'm looking
Mhm.
for excuses to minimize the impact of that China and the threat that China might pose to my energy status quo, or the energy status quo of my country, my region. And this is not a technical question, but because you work in this space and I kind of, and you're in another continent, I'm just kind of curious what your thought is about that.
Yeah, I mean, as you alluded to, I think some consistency in the policies put forward would be helpful in and of itself, right? So that industry can invest with some certainty, and that's been part of the problem in Europe and obviously recently in the US. Um, the environmental aspect in Europe is certainly important, and that's another area where there may be scope for quote unquote a green premium from materials that have been sourced from from greener operations. Having said that, some of the bigger players in China are also kind of moving in that direction and starting to report on CO2 emissions, water consumption, so on and so forth. Because if they are looking to enter European or US markets, that's going to be important for them as well, and they recognise that actually expanding outside of the Chinese domestic market is going to be a key growth lever for them. Um, so yes, there are environmental issues still with China and the battery supply chain more broadly, but from our perspective, these are all, that for the most part being worked on, being improved, and certainly, looking at battery tech, EV tech, so on and so forth. They're such key enablers to moving towards a lower carbon kind of economy that you have to deal with these certain cases, irrespective, and it's still going to be on the whole a better, system.
Do you think the Western governments are doing a good job of, building political support for the kind of policy changes that are required to support clean energy manufacturing so that the West can catch up to China?
Uh, Ultimately, probably not as good a job as you'd want. I think we go back to maybe talking about things around, energy security and having, that's not to close specific regions off from any other, but having some diversification in supply chains, having some security that you're not reliant solely on one region, one actor, I think is important. And that's where I think, maybe some of the discussion could have been rather than just pushing it on, clean energy. But ultimately, you can make very valid arguments that this, in the long term, can be seen as an investment in jobs, in lower cost of, energy, transport, whatever it may be. So some of that, making some of those arguments might have been useful. And I think that maybe there's been a few tricks missed in
Yeah,
the past.
I would have to agree with you. I mean, during the Biden administration, I spent a lot of time reading speeches by people like Brian Deese, the head of the National Economic Commission, or the economic advisor to President Biden. And it's very clear that around 2021, 2022, the focus shifted within the administration to the national security implications of relying on Chinese supply chains of all sorts, and realizing that if there's any kind of conflict that arises with China, you cannot be, and so China becomes the enemy, maybe a military opponent, then in that case, you cannot be relying on your opponent's supply chains, which could be a vital part of, your military industrial complex. And so there's a certain part of this where you say, okay, we'll even take higher costs and we'll invest public monies to build those supply chains because it gives us national security, it gives us energy security. There's a lot of other, sort of benefits to it that can't be measured in dollars and cents. And then, of course, all of that disappeared when President Trump came on board. But that does seem to be an increasingly important uh, consideration for governments, is that whole national security, energy security issue going forward.
Yeah, absolutely. And we've seen these, critical materials lists come forward from the EU, from the US. So certainly that is starting to become a part of the conversation. But also, it's ultimately going to be a responsibility of industry to develop those battery technologies, those systems, stationary systems, EVs, so consumers ultimately would prefer those choices over whatever incumbent it is. And as mentioned kind of previously, we're relatively optimistic that those innovations are coming forward, which allow that to happen. Um, it's how much of that industry the West, the global North, wants to keep hold of.
Yeah, fair enough. Alex, always a pleasure. Thank you very much for this.
Great. Thank you very much.